Hi, this is P8.2, solving linear equations. And they give us some samples of how the linear equation is going to look. You don't need to know much about this part, it's just to know that there will only be one variable. You're not solving for both x and y. And in this case, they're saying when you divide, you can't divide by 0. A cannot be 0. So your denominator can never be 0 because then we know your calculator will say error, undefined. All right, moving on. These indicators say, I know that x and y values from an equation can be plotted on a graph. So you can take any equation with x and y in it and use those values to create a graph on a Cartesian plane. I can use multiplying, dividing, adding, and subtracting to find x and y values. And that's basically what this top information is showing. It's just all the different operations. So when a is multiplied by x, when a gets divided by x, when x is added to something, or maybe divided and then added or subtracted. And this one is going to show distributive property, which we will get to in a minute. So there was distributive property there. Identifying situations in real life that can be shown on a graph in a linear equation. So linear equation means it's going to make a straight line on your graph. I can translate English sentences into mathematical symbols, and so we've got some examples of that, but basically if you're saying the word is, you know that that means equals, and you can write your equal sign on the paper. I can solve a linear equation, so solving for x, finding the value of the variable, and doing that, I'm just going to skip down, you're going to use preservation of equality, keeping the scale balanced. What you do on one side, you have to do to the other side. Modeling linear equations with counters or a drawing, testing a solution to see if it actually fits in that equation, correcting errors. We just discussed this one about why a cannot be 0, because you can't divide by 0, it's undefined. And solving problems using graphs of linear equations. So let's have a look. This slide I think I had in the grade 7 videos as well. This is just preservation of equality. So if you're going to solve for one variable, if they've added, you're going to subtract. If they are subtracting, you're going to add. If they're multiplying, so you're always doing the opposite to get that x all by itself and alone. So let's look at y plus 14 equals 20. The opposite of plus 14 is minus 14. And so the y was not all by itself on that one side. It had this plus 14 stuck to it. So this person thought, boy, I wish I could just take away 14 and then the y would be all by itself. But what you do to one side, you must do to the other. So if I'm going to draw a little minus 14 underneath that side, I need to do the same thing on the other side of the equal sign. So these two cancel each other out. 14 minus 14 is 0, so there's nothing left there. And 20 take away 14 is 6, so y equals 6. Let's have a look when they're using subtraction. We have a negative 120 here, so we want to add 120 to get rid of that, and then this side is gone, cancels itself out. What I do to one side, I must do to the other, so if I've added 120 on the left side, I need to do that to the right side. And x is naked and alone, and 80 plus 120 is 200. In the multiplication example, we have 3n equals 12. So because the 3 and the n are stuck tight together with no sign in between them, that means they're being multiplied. What's the opposite of multiplication? Division. The best way to show division is with a fraction bar, and so they've drawn a fraction bar and put a 3 underneath like that because originally they were thinking, boy, I wish I had a 3 on the bottom of that fraction so that I could cross that off and just have n all by itself. And so then what they do to this side, they must do to the other. If you've drawn a fraction bar on one side, you better draw a fraction bar on the other side. And if you put a 3 as the denominator, you need to put a 3 on this side. And 12 divided by 3 is 4, so n is equal to 4. The last one is division. So they started with a fraction. K was getting divided by 2, because a fraction bar means divide. And Halloween bug. And so they thought, boy, I wish I had a 2 on the top of that fraction so that I could get rid of that and get rid of that. And what they mean when they put the 2 on the top of the fraction, they're multiplying. So they're putting that 2 beside the k, and they actually used a multiplication symbol, the x there. So if I'm going to multiply by 2 on this side, I need to multiply by 2 on the other side, and my k is all by itself, and I've got 16 times 2 is 32. These are some examples from the SCMA for this outcome, so you'll be excited to know that here are the answers. It could show a picture and ask you what linear equation is represented by this picture. So we have a balanced scale, and we have a bunch of blocks, 3 of them, that are all labeled x minus 2. So how would you represent that in mathematical language? And then we also have these two dots over here. So what I would say is there are 3 x minus 2's, and that is equal to, because the middle of the scale is your equal sign, and we've got our 2 dots. So 3x minus 2 is 2. Okay, here are some examples of just solving an equation using preservation of equality, just like we did on the last slide. So the x is not all naked and alone. It has a fraction bar and a minus 4 as a denominator. What do you wish you had on the top of that fraction so that you could cross that minus 4 out? Well, I wish I had a minus 4. So I'm going to multiply, just stick some brackets in here, multiplying my x by negative 4. And that will be able to cancel out because minus 4 over top of minus 4 is 1. Anything over itself is just 1. And if I've multiplied by negative 4 on one side, I need to multiply by negative 4 on the other side. Okay, so the only thing that is left from this side of my equation is just the x. And then I drop down my equal sign, and then I can type into my calculator 77 times negative 4, so I'm going to get negative something, something, something. I'll have to figure that one out. Let's try this other one over here. X minus 14 equals negative 27. So what's happening to the x right now? It's not being multiplied, it's not being divided, it's not being added to, it is being subtracted from. So we have this minus 14 right there. Well, what's the opposite of minus 14? It is plus 14. And if I'm going to add 14 to that side, I need to go over and add 14 to this side as well. Okay, so these two cancel each other out because they're opposites. And I'm left with just my x on that side of the equation, my equal sign, and negative 27, adding 14, so adding 10 would be 17, and adding 4 would be, so x is negative 13. In this last example, you have to use distributive property. So the 3 has to go with the x, and it also has to visit with the 8. So what is 3 times x? 3x. What is 3 times 8? 24. And then we can do this next chunk. The 2, because the brackets mean multiply, that means the 2 is going to be multiplied by everything inside, starting with the x, so minus 2x, and negative 2 times negative 6 is plus 12, our equal sign, and our 14. Now we can gather up like terms. How many x's do we have? Well, there's 3 of them there, and there's minus 2 of them here. So all together we have 1x, or just x. We have 24 and 12, which equals 36, is 14. And now we can subtract our 36 from both sides. Okay. 14 take away 36, I will let you do the calculations on that to find out what x equals. When you're reading story problems, you're going to come up with all kinds of words, and you need to know how to put those into the language of math. So we've already talked about the fact that is means equals. There are a lot of other words that could also mean equals. So equals, it totals, it adds up to, is the same as, results in, they all mean equals. Of means multiply, and it's usually when you're talking about percent, because they'll say 20% of, what they mean is 20% times that number. And percent, of course, means out of 100, so you're going to make a fraction out of that one. So here's a little example. It says Bill is 3 times older than his daughter, and in 1 year their ages will total 50. How old are they now? So these are kind of fun to figure out. So let's call Bill B, and let's call the daughter D. Okay, so we've got two variables going on here, and we have the word is, so I know it's going to be an equal sign there. Bill equals 3 times older than the daughter. So 3 times, it actually says the word times in there, so we know it's going to be 3 times. So I've used brackets as my multiplication symbol. So Bill is equal to 3 times D, or B equals 3D. Okay, so there's one equation. It also says in 1 year, their ages are going to total 50. So Bill's age plus 1 plus the daughter's age plus 1 all adds up to 50. Interesting, hey? So we could actually figure this out. B plus D plus 2 is 50. Or B plus D right now is 48. Sorry, I didn't show you how I did that. I'm going to subtract 2 from this side and subtract 2 from this side. So those guys are gone. 50 take away 2 is 48. So I've just simplified that one. Now I'm going to go back up to that top equation, B equals 3D. So if these two things are the same, B is exactly the same as 3D's, I'm going to take that 3D and I'm going to sub it in right there. So instead of putting a B here, I'm going to sub in something that's exactly the same. So 3D plus D is 48. This is maybe a bit advanced for grade 8, but it's kind of fun. 4D then, because we're gathering up our like terms, is 48. So 3D plus D, that's 4 of them, equals 48. 4D equals 48. And now I can divide. Don't I wish I had a 4, yep, on the bottom. And I can cancel those out and just have plain old D. But if I divide by 4 on that side, I need to divide by 4 on this side. And so D is equal to 12, because 48 divided by 4 is 12. So now, remember this original equation. If D is 12, how old is B? 3 times 12, my picture's covering this up, 3 times 12 is 36. So the dad, Bill, is 36. Cool, hey? Okay, we have an example of an equation up top here, y equals 2x minus 3. And this is an example of a linear equation. And so any equation can be shown, anything with y's and x's is generally going to be able to be shown on a Cartesian plane, so on a coordinate plane. And this equation, I think the indicator says that you should be able to look at an equation and see what numbers fit in it and be able to draw the graph and maybe show it in a picture. So let's have a look at our 2 points first of all. This one is 2, 1, and remember that you're always starting at the 0 and you're always plotting your x value first, your horizontal value first. And Noah told me that you should go in the house and then up the stairs. So get in the house first, then go up the stairs, which I thought was a fun strategy. So in this case, your x value is 0 and your y is -3. So in the house, there I'm done because it's 0, and then you're -3. 1, 2, 3. So there's that point and our initial point. And you can see that the line has been drawn right through them. So those 2 points satisfy the equation. You could actually put them into that equation and it would work. So let's take these coordinates right here and we're going to plug them into the equation. So the x value I said is 2. So anytime you see an x, there's one right there, you're going to plug in your 2. And anytime you see the y, you're going to plug in your y value, which was 1. So let's see if this actually works out. 1 is equal to 2 times 2, take away 3. Well, 2 times 2 is 4, minus 3, that does equal 1, so it checks out.